Hello and welcome to Train Signal. You are watching Job Scheduling. Think of all the tasks that you perform as an administrator and then try to categorize them into actions that don't require your input besides the initial command in order to run. A few things that come immediately to mind are a log file viewing and maybe some file cleanup tasks and backups. And I'm betting that the number of administrators that wouldn't appreciate even the smallest amount of time savings from automating some of this work are few and far between. Luckily, Linux has a tool to help automate these functions, called cron jobs, and in this lesson, we'll review them. Cron jobs do have a limitation though. They won't run if the system isn't powered on. So we'll talk about another tool, Anacron, which works alongside cron to check and execute cron periodically, ensuring that your cron jobs always execute. And finally, for those times when you want to run a job once at a specified time, we'll review the @ command. Let's take a look at cron on the next slide. The cron program is a daemon, and we learned that daemons hang out in the background and come to life when some action or event triggers it to do so. So once every minute, cron D awakens and checks the files in var spool cron and etccron.d, along with the contents of etccron tab for any specified cron jobs. Cron is perfect for those jobs you need to run on a set schedule. The etccron tab file is used to configure what job should run. It checks the scripts in 4 directories: etccron.hourly, etccron.daily, etccron.weekly, and finally etccron.monthly. Anything found in these directories by cron is run according to the specified schedule, and that's hourly, daily, weekly, or monthly. You only need to create a script file and put it in the right directory. But if you need to run on another schedule outside of those indicated by these directories, you just need to create the text file and store it in etccron.d. There are 2 types of cron jobs: user and system. System cron jobs are created by root and used to perform system maintenance. There are several default cron jobs included with your distribution. One in particular is used to clean out the temp file directory, and that's /temp, and another performs log file rotation. The etccron tab file is composed of environment variable declarations, followed by lines which outline all the cron jobs. The format is as follows: time, followed by the account name that's creating the cron job, followed by the command that needs to be executed. The first 5 fields are for time, in the order first of minute, which is expressed with the numbers 0 to 59. Then you have hour, expressed in the numbers 0 to 23. Then you have day of the month, numbered 1 through 31. The actual month, 1 through 12. And finally, the day of the week, numbers 0 through 7, and 0 and 7 both represent Sunday. Other characters that you may see in the date fields include the asterisk, which as we know is the wildcard character, and this says match all occurrences. Then you have a comma, in which the comma separated list represents any of the values indicated. Then you may have a dash, which indicates a range. And finally, you could have the /, which represents what's called stepped values. So a /10 would mean every 10 minutes. And again, next you would have the account name, which could be root or could be a user's name. And then finally, you will have the command to run. Let's open a terminal window and view the contents of our etccron tab file. From our Applications menu, let's go to System Tools and Terminal. Now to view the copy of etccron tab, we're going to use the cat command, cat space etccron tab, and hit enter. What we see here is some environment variables at the top. We've got our default shell, we've got the default path, the default mail to user, and the default home directory. Then we've got some comments here which detail syntax and format. Noticeably absent are any cron jobs. If this were a live server environment, you'd probably have several entries here. Now let's view some of the other directories. Let's type in ls space /etc /cron.hourly and hit enter. We can see that we have one job here that's in the hourly category. Let's check out daily. Use our up arrow key. Let's backspace and type in daily and hit enter. And we have actually several cron jobs that are set to run daily. Again, these are default cron jobs, and if you actually wanted these to run, then you would need to edit the etc cron tab file and set up a line that would indicate which job you want it to run. We've got cups, which is a printer program, got log rotate, and a few others. Let's see what we've got for weekly. Use the up arrow key. Let's go back and type in weekly and hit enter. And we just have one cron job there. Seems like a RAID check for a network that might be using RAID. Now let's see what we've got finally for a monthly. Use the up arrow again to go back to the previous command. I'm going to backspace and type in monthly and hit enter. And again, we just have one job there. Let's take a look at the contents of that log rotate file just to get some examples of format. So let's type in cat space /etc cron, and we knew that was in daily. Here it is right here, cron.daily, and the name of the cron tab, which is log rotate, and hit enter. And we can see here again that the shell is set. Then we've got the program that needs to execute, which is log rotate, and then we're sending that to output, and we've got some if commands followed. So that gives you an idea of the syntax of a typical cron job. Okay, let's go back to the presentation and find out how to create our own cron jobs. Some administrators may be a little leery of allowing this, but again, individual users can create their own cron jobs. In order to create a cron job, users can use the cron tab utility. The command syntax is cron tab space options space file name. And the options are -u, which is used to indicate the user, -l, which can be used to display the current cron jobs, -r to remove a cron job, and -e to edit a current cron job, and it uses Vi as the default editor. -e is also used to create. As an alternative to this method, you can create the cron configuration file with cron tab -u space username space file name. To include environment variables, you simply use the variable equals value syntax that we saw in our etc cron tab file. So a typical command might read cron tab space -u space tsmith, who was our test user from our last lesson, space mycron, which is the name of the cron job. User cron jobs are stored in different directories than their system counterparts. Typical locations are var spool cron, var spool cron tabs, or var spool cron tabs. And of course, this is dependent upon your distribution. You can control access to cron by setting permissions like executable programs, but you can also use files to allow or disallow access, namely etc cron.allow and etc cron.deny. And those do exactly what the names indicate. Let's go to our terminal window and create our first cron job. First, let's clear our screen. Then let's type in cron tab, the utility to create a user cron job, space -e, which is to edit or create a new file. Go ahead and hit enter. And again, this will open up the Vi editor that you should be pretty familiar with by now. And to enter insert mode, we use either the I or the A. So I just went ahead and hit the I. Now, using the format that we learned, I'm going to first type in the minutes. And I'm going to make it 45. For the hour, I'm going to use 13 or 1 o'clock, so this is 1:45. And for the remainder of the time fields, I'm going to leave those wildcards. So we'll put in asterisk for day, asterisk for month, and another asterisk for day of week. Then we're going to put in the command, and I'm just going to do a tar command which will do a backup. Bin, since I know the path of tar is bin tar, put in some options to create the tar file. Then we're going to say where to store it. I'm going to store it in the home directory. And we're going to call it my backup .tar. Finish that off with a tilde and a /. Now let's hit exit to enter command mode again. I'm going to hit the colon and WQ to write and quit. And hit enter. And you can see here that it says installing new cron tab. Now let's take a look at the cron tab by typing in cron tab with the -L option to display. And we see our cron job here. Again, at 1:45, it should go out and do a backup and store it in the file mybackup.tar. So cron is probably good for servers because we know that servers generally run 24 hours a day, 7 days a week, 365 days a year. But what about your users who have desktop systems and laptops even that usually shut down at night? If you recall, cron can't run on a system that isn't booted. So to solve this quandary, we have the Anacron tool. Anacron keeps a record of programs it should execute and how often it should do so in number of days. When Anacron runs, it checks to see when it last ran each of the programs that it manages, and it determines if it needs to run it again based on the times. Since Anacron, like cron, is launched via startup script, we know that it's always running. And it's for this reason that you might want to consider reconfiguring your cron jobs as Anacron jobs. Anacron's configuration file is etc Anacron tab, which contains comments, environment variable settings, and what's called job definitions in the format of period, delay, identifier, and command. Period is the program run frequency in days. Delay is the delay between when Anacron starts and when a program runs. Identifier is the string that identifies the command, and command is the command to be run. Let's go over to a terminal window and take a look at our own Anacron tab file. From the command prompt, let's type in cat space etc Anacron tab and hit enter. And as you can see in our Anacron tab file, we have some comments here to start out. Then we've got some environment variables set, namely the shell, which is using bash. We've got the default path. We've got the mail to, which is going to go to root. Again, as we talked about, usually results are mailed to root unless you want to have them sent to a file. Then we've got some other comments here. And then we have some actual jobs. And when they're scheduled to run, we've got some daily, weekly, and monthlies. Okay, let's head back to our presentation and see how the @ command fits into this picture. Cron and Anacron are probably most often used by administrators or power users. But for the regular user, there's the @ command. @ lets you run a single command at a time in the future that you designate. The @ daemon must be running on your system in order to use @. ATD is stored in either etc init.d or etc rc.d/init.d. This is, of course, depending on your distribution. The syntax for @ is simply followed by the time of the day in format of hours and minutes, with 2 characters for hour and 2 characters for minute. You can indicate AM or PM if you'd like, but it's not required. And there are also 3 keywords that you can use: noon and midnight, which are self-explanatory, and oddly enough, tea time, which is 4 p.m. If you want to schedule more than 24 hours in advance, you can add the day in the format 2 characters for month, 2 characters for day, and 2 characters for year. Now you can do that with no slashes or dashes or anything, or you can include forward slashes or periods. Another cool option is the now keyword. You can indicate now plus the time that you like. For example, at space now space plus 5 means to execute 5 hours from now. And the results of at will either be emailed to you or sent to an output file. Other at commands include ATQ, which lists pending jobs. Then you have ATRM, which removes a job from the queue, and this is by job number. You also have batch, which is used to execute a job when the system load drops below 0.8. This is the command to use when you want to execute your job when the system is a little less busy. And like cron, you can control access with either the etc at allow or etc at deny files. But if either of these doesn't exist, only root can use at. This is the direct opposite of cron, where everybody has access if the files don't exist. Let's go back to our terminal window and try out this command. First, let's make sure the at daemon is running by viewing the contents of etc initd. So from the command prompt, type in ls space etc init.d and hit enter. And as we can see, the daemon is running. You see ATD right here. Now let's try out the command. Let's type in at, followed by, we're going to use the now keyword, plus, and I'm going to say 2 minutes. And if we hit enter, we should receive an apt prompt, which is the at keyword followed by the greater than sign. And now that we have the prompt, let's go ahead and enter a command. I'm going to enter the tail command so that we can look at the last 10 lines of a log file. So let's type in tail space var log messages. We're going to direct the output to a file with the greater than sign. Then we just need to say where we're going to store it. So I'm going to store it in the home directory, which tilde is the shortcut. And we're going to call the file logoutput.txt. And to end our input, we hit the Control D. And we can see here that it says job 3 was created and the date and time. Let's type in ATQ. And as you can see, ATQ, which is the command to list any pending jobs, shows the job number, the day, the date, the time, and the user that created the job. Another thing to note is that I can't see jobs of other users, but if I was logged in as root, then I could see the jobs of all users on the system. Now in 2 minutes, since we set with the now keyword, we set it for 2 minutes, we should look in the contents of our root directory, of our home directory, and see the log file. First, let's type in ATQ and hit enter. And we can see that that job is no longer listed. But we do see that I have some mail that I need to check out, which I will do later. Well, what this tells us again is that the command executed, and if we look in the contents of our directory, we should see the file. So let's type in ls. And we do indeed have a file called logoutput.txt. Let's see if we have any content in that file. Let's type in cat space log output.txt. Now this is a test system, so we may not have anything in there, but you get the general idea. That concludes our lesson on job scheduling. Let's go over what we've learned on the next slide. Think for a moment about everything that we did in this lesson. We've used commands like ls, cat, and tail. We also used the vi editor, and that's in addition to all the new material. What you should glean from this is the fact that the earlier building blocks that we laid set the foundation for the latter material and that is still yet to come. So to review what we've covered in this lesson, we learned that cron jobs can be used to schedule and run commands, typically maintenance and other administrative functions. We took a look at some of the default system cron jobs and then created our own. We also learned about the anacron tool, which ensures that your cron jobs run whether the system is on or not. And finally, we covered the at command and how it can be used to schedule one-time jobs. Thanks for watching, and I'll see you in the next lesson.